slope and deflection. So whenever a cantilever or a beam is loaded, it deflects from its original positions. Cantilever is one side is fixed. This is cantilever, and any beams, simply supported beam or any others, is loaded. It deflects from its original position. If it is simply supported, it deflects in this fashion. The amount of deflection by which the beam is deflect depend upon its cross section and the bending moment. If the cross section is rectangular, if the cross section is square or rectangular, it depends upon the type of material used and the type of section used. It deflection amount will, this is the deflection amount, let be y. We are considering the two design criteria for the deflection of a cantilever or any type of beam. One is strength and another one is stiffness. Number two is stiffness. As per the first one is considered, whenever considering as per the strength criterions, the beam design, it should be strong enough to resist the bending moment or shear force. Or in other words, the beam should be strong enough to resist the bending stress and the shear stresses. In case of the second criterion, we are considering, that is stiffness. The stiffness criterion of the beam design, which is equally important, it should be stiff enough to resist the deflection of the beam, or in other word, the beam should be stiff enough not to deflect more than the permissible limit. So what is permissible limit? That is one word is using permissible limit. As per the Indian standard specifications, these limits is, that is span per 325. This is standard specification we are considering as per. Under this action of the loading, the actual practice, some specifications are always led to the limit of maximum deflection of the cantilever or beam to a small fraction of its span. Okay, now come to discussing about the different methods of slope and deflection at a section. There are two type of method. One is double integration method. Another one is Macauliffe method. One is double integration method, and second one is Macauliffe method. Today, first one is discussing what is double integration method by a slope deflection. So as we know, first one is we are discussing double integration. Okay, as we know that the bending moment at a point, bending moment at any point of a beam section is, previously we are find out EI d square y by dx square. Let me equation 1, previously discussing this equation. Now integrating the above equation, we get the above, we get ei dy by dx is equal to integration of m. Let me equation 2. Now again integrating we get ei into y, that is equal to double integration of m. So in the above, let me equation this second. In this equation, what we find out, the first integration of the original differential equation, we get the value of slope positions. This is slope values or slope at any point. In the further integrating, we get the value of deflection at any point. Deflection value we get. So this is the first method, that is a double integration method for a slope and deflections. So next class we are discussing about the Macaulay method. Okay.